Okay, now, let's just plug into the formulas. The derivative of u1 with respect to x is minus, right? What's it? You think I'd know this by now. Minus y2f over the Wronskian. Sine 3x times f of x, which is a quarter cosecant 3x, divided by the Wronskian, which was 3, right? Minus y2f sine 3x. Where does it have divided by the Wronskian? Okay. And what does that come out to be? Boy, pretty easy here. Minus the 12, right? Because the sine and the cosecant are obviously reciprocals of one another. Okay? So it's obvious if we integrate that u1 of x is just minus x over 12. And again, I remind you, what happened to the constant of integration over here? You could put it in, but then when you form the product u1, y1, you'll just pick up a multiple of cosine 3x, which already is in the homogeneous solution. So you just be accounting for it twice. So you don't have to do that. Okay. And now, what's the derivative of u2 with respect to x? I believe it's y1f over the Wronskian? Yeah. So what's my y1? Cosine 3x times f of x, which is, don't put that quarter, cosecant 3x, y1f, divided by the Wronskian, which is 3. So that's 1/12, right? And now you can say, that's cosine 3x upstairs, and then downstairs we have sine 3x. Okay, and you say, oh my God, how am I going to do that integral? Okay, well, if you look at this, notice basically that you have something in the denominator which suggests a log, and fortunately in this case, you got the derivative of that thing upstairs also, except for a constant, right? Cosine 3x. Okay? So if I integrate that to get u sub 2 of x, let's see, what adjustment do I need? If I do another factor of 3, I guess 1 over 36, I'm thinking, times the logarithm of the sine of 3x. Let's pause here and differentiate, make sure it's right. Get 136, root of log, I get 1 over sine, good. Then a cosine upstairs, and a factor of 3. 3 over 36 is a 12. Okay, so that's u2 of x. Check out my u1, I got my u2. Okay, I now know my particular solution. My particular of x is u1 times y1. What do I get for u1? Minus x over 12 times y1, which was cosine 3x, plus u2 y2, plus 136 y2. That's a sine 3x. And don't forget the log term of sine 3x. Okay? Let me just check the notes here, make sure I don't lead you astray. So, particular solution, minus x over 12 cosine plus 136 sine left. Yes, okay. And the complete solution, y of x, of course, is just the complementary solution, which you have right over here, right? Plus the particular, which you just have right above. And that's the most general solution to that second order linear equation with that weird side, right-hand side of cosecant 3x. And again, there are two arbitrary constants in that solution from OIC because I haven't given initial conditions. Okay, maybe I have one here that involves initial conditions. Okay, and okay, this is the last one I'm going to do now. Unless there's any questions on that. Okay, example number 3. Okay, everybody got the email, right, that no class Monday and Wednesday? Mm-hmm. Okay. And there'll be a makeup, actually, I'm coming in tomorrow to take the one, I guess, one of those makeups, and the other makeup will be some other time. And I got one reply that someone tried CSUN Bucks. I don't know who it was.
That was me.
Where did it come from? It came from, like, Chase. Didn't have your name on it.
I don't know why that does
Okay,
that.
Okay,
Yeah.
Okay, so no one else tried to see Sunbox? Well, okay, don't. It didn't work. Did it work?
The that you sent, it had a video already
Yeah.
uploaded to it, so what's that?
Oh, that was just a test, it was just a test, to make sure that, you got your account right and stuff like that. Yeah, that video you can watch, but I think I took one from I did last year, and it was on the method of constant coefficients, actually. So you have another one for review. But that wasn't the one that was made up. That's gonna come tomorrow on Friday. Okay, here's the last one. X squared, second derivative of y with respect to x, minus 6y equals x cubed log x. Wow, x cubed log x. Okay, so on the left-hand side I got x squared y double prime minus 6y equals x cubed log x. Now this one, of course, got both of those conditions in it, right? Cannot use the method of undetermined coefficients for two reasons. It's a variable coefficient equation. L on y contains x squared, not a constant. And the right-hand side obviously has an infinite family, right? X cubed log x, you keep differentiating, you'll never stop. Okay, so you must use the method of variation of parameters. The problem here is that you haven't been told how to solve the homogeneous equation even, right? Let's look at the homogeneous equation first. That's the one that we solved first. It's going to be x squared y double prime minus 6y equals 0. I can't give that to you on the exam now, right? Because you haven't learned that. Actually, the next topic, we're going to do that. But for the purposes of this exercise, I'm going to tell you what the two homogeneous solutions are. You should at least verify it. But actually, what we're going to do later, whatever time is left today, we're going to actually look at equations like these. A certain type of equation occurs a lot in practice, and we actually can solve it. Okay, at this point, okay, I'm just telling you, y1 of x, what were the two fundamental solutions over here? It's x squared y double prime minus 6y is x cubed log x. Okay, one solution is x cubed, and the second homogeneous solution, y2 of x, happens to be x to the negative 2. Okay, I urge you to check all those. And in fact, the first one you can do in your head, right? What's y1? X cubed. If I differentiate twice, I get a 6x times x squared, 6x cubed minus 6x cubed, right? And the other one also you can do, pretty quickly. Okay? So I don't expect you to know this. I'm telling you, at this point, I'm telling you those are the two homogeneous solutions. Okay. Okay, now I'm on my own at this point. Okay, so what do we do for the particular solution? Y sub p of x. Okay, right? We have the first solution, x cubed times u1 of x, which I don't know, plus the second fundamental solution, x to the minus 2 times u sub 2 of x. Okay? Now, let's be very careful also. We're going to use this formula over here, but again, okay, I can't overemphasize the importance of this. The formula assumes that y double prime coefficient is 1, okay? So all you have to do over here is divide by x squared, right? So now, basically, my f of x, which is the right-hand side, when it's in that canonical form, is x cubed log x over x squared, which is x times the log of x. Again, if you got to do that, you'll get an integral that's going to be very, very intractable, okay? So maybe, that's one of these things where, if you're doing this type of problem and you find something like, gee, this integrals take me forever, right away you think back, maybe I forgot to divide through by the coefficient, okay? Okay, so we've got f of x, we've got the two solutions. Okay, let's get the Wronskian over here. Okay, the first row is y1, y2, so we have x cubed, and then we got x to the minus 2, right? Now I differentiate that guy, I get 3x squared, right? And here I get minus 2x to the minus 3. Okay. If I take this determinant, it's minus 2, this times this is minus 2, minus 3, which is negative 5. Okay, so the Wronskian is non-zero, sure, because they're linearly independent solutions. Okay. And now we just plug in to our formula. Okay, we know that the particular solution is going to be, here it is, x cubed, parentheses, u1, y1, u2, y2. Okay, let's go for u1 prime. u1 with respect to x equals, I need a negative, but in the Wronski, I don't have a negative, so I'll put 1/5 for that, okay? Plus 1/5, okay? Okay, second solution, f of x. Second solution, x to the minus 2 times f of x, which is x log x. Okay, so the derivative of u1 with respect to x is 1/5, right? Log x over x. And again, I got the derivative log x down there, so maybe if I took a power like log x squared, it'll work out. So u1 of x, I think it would be 1/10 I'll get over here. And then I get the log of x, the whole thing squared. All right, let's use the power rule to check this. I have a 1/10, 2, which gives me a 1/5. Log x to the first, through log x is 1 over x. Okay. So that's the u1, that was pretty easy. And now, what about the derivative of u2 with respect to x? Okay, with respect to x, Wronskian, so I'm going to get a -5 over there, right? Because Wronskian is -5. Okay? y1 of x, f of x. What's y1 of x? It's x cubed times f of x, which is x log x. Okay? So the derivative of u2 with respect to x is minus a 5th, right? That's x to the 4th times the log of x. Now we have to integrate x to the 4th log x. Okay? So let's see what that gives us.
For the line u1 equals, is that 1/10?
1/10.
Yeah.
Take the derivative, you'll see the derivative. Okay, so what's the integral that I have to do? I have to find the indefinite integral of x to the 4th log x. Let me write that as log x, right, times x to the 4th dx. Obviously, I'm going to use integration by parts. That's why I put the log x first. X to the 4th log x. Okay? So let u equal log of x, well then du is going to be just dx over x. Right? And let dv, the other part, be x to the 4th dx. Right? Is that the integral of the u dv? And therefore, v is obviously x to the 5th divided by 5. Okay, so integration by parts formula, the integral of log of x times x to the 4th dx, so the integral of u dv, I got uv, right, what's uv? X to the 5 over 5 times the log of x, right? uv, log x, x to the 5th over 5, uv, minus the integral of v du. And the du is dx over x. Okay? So that becomes 1/5 x to the 5th log of x, okay, minus 1/5 the integral of x to the 4th dx. That is very simple. So we get 1/5 x to the 5th log of x minus, I guess, 1 over 25, right, x to the 5. Okay. Just now it's getting a little bit messy, though. Okay, I need u2. U2 basically is I take this result and multiply by negative a 5th. Right? Right? Because u2 basically has a minus 1/5 times the integral, which I just did. Hit that with negative a 5th. I get minus 1 over 25 x to the 5th log x, minus the 5th I said, plus 1 over 125 x to the fifth. Okay, so that's the U2. Okay, and not to go through the algebra, okay? Now you can form the particular, right? Where are we? Here. X cubed times U1 of x. That's here someplace. Yeah, there's U1 of x, right? And then we have x to the minus 2 times this mess for U2 of x. And you simplify that a bit, okay? And I'll tell you what you get. What you get for the particular solution, therefore, y sub p of x is equal to x cubed divided by 10, the log of x whole thing squared, not so bad, minus x cubed over 25 times the log of x. Okay, that's the particular. Okay, and of course the general solution y. Remember, if the problem says give the general solution, you must remember that it's y sub c of x plus the particular. Okay, here's my particular, and yc is someplace over here. Right? Yeah, yc would be c1x cubed plus c2x. Maybe I should write that down. Okay? Right? The homogeneous solution, we found two independent solutions to be x cubed x to the minus 2. So we'll have c1x cubed plus c sub 2 x to the minus 2 plus this mess over here, yp of x. Okay. That's the general solution to the differential equation. Okay. Okay, so what happens now is that we're going on to a topic called the Cauchy-Euler equation. And by the way, after we cover this, there'll be an exam, and I'll, so just, stay alert. I'll post it on Moodle, and I'll send out an email. I'm not sure exactly when the date would be. If it wasn't off those, 2 days, I would have probably given it then. But what we have to do, though, is the following. We have to cover this Cauchy-Euler. Okay, if we don't cover it, we don't cover it. Okay, today. I don't think we're going to finish it today. So, but certainly there'll be some homework on the method of variation of parameters, which I'll put up today. Again, I'm not going to collect it, so you'll have a folder there with the problems and the solutions. Obviously, you want to try it without looking at the solutions. Okay, and then another homework assignment on Cauchy-Euler. Okay, and then there'll be an exam, and I'll give you, all the topics on that. So hopefully, I don't want that exam to be too late. Like, I'd like to get it certainly